Hi students, in this class I am teaching to you a topic in the lesson dual nature of radiation and matter. The name of the topic is de Broglie hypothesis. What is the name of the topic? De Broglie hypothesis. So this topic is very important for all competitive exams. Okay, just take a brief look on these topics, whatever the formula we have in this lesson, de Broglie hypothesis. Okay, so at first, as you know that the first and the best important formula for the de Broglie hypothesis is de Broglie wavelength. What's that? De Broglie wavelength. The de Broglie wavelength is equal to lambda is equal to, here we are taking that h by p. Lambda is equal to h by p. P is nothing but momentum of the moving particle, which we consider either electron or proton or neutron or deuteron, whatever it may be. The de Broglie wavelength is equal to lambda is equal to h by p. Here p is the momentum of the moving particle, and that is p is equal to mv, mass into velocity. M is the mass and v is the velocity. Okay, so now in this class I am teaching to you a brief glance related to the whatever the formula we are using in the concept of de Broglie hypothesis. Okay, at first here I am taking that lambda is equal to h by p and thereby h by mv. Then with this we are taking the concept as lambda is inversely proportional to mass as well as velocity, m and v. These two are mass and velocity, these two are in the denominator, and that's why here lambda de Broglie wavelength is inversely proportional to mass and velocity. With that we are taking that lambda 1 by lambda 2 is equal to m1 by m2 into, here once we consider the part that is here m1 by m2 into v1 by v2 or v2 by v1. Now here we are taking the concept once we are taking that here m1 lambda 1 by lambda 2 is equal to this mass and velocity is in the denominator, and that's why here we are taking that m2 by m1 into v2 by v1. Otherwise lambda 2 by lambda 1 is equal to m1 by m2 into v1 by v2, like this. Lambda is inversely proportional to mass into velocity. Here mass and velocity both are in the denominator, and that's why here we are taking that if you are selecting the first value here, then here the second values of the two physical quantities we used to consider. And next, so the other one is nothing but the relation between the de Broglie wavelength and the kinetic energy of a particle. De Broglie wavelength, lambda, and kinetic energy of a particle. So as you know well, and that is here lambda is equal to what's that? h by mv, mass into velocity. This itself is, here we are taking that h by p also. In the mechanics we have one relation between the kinetic energy and momentum. Ke is equal to what's the value? P square by 2m. Ke is equal to what's the value? P square by 2m. Thereby here P square is equal to what's the value? 2m into Ke. P square is equal to 2m into Ke. Then P is equal to root over 2m into Ke. Substitute this value in this equation. Lambda is equal to h by root over 2m into Ke. Here Ke represents the kinetic energy, m is the mass of the charged particle, and h is the Planck's constant, as you know that. Now with this we are taking the relation between the lambda, mass of the charged particle, as well as the kinetic energy of the moving particle, and that is nothing but lambda is inversely proportional to root over m into Ke. Root over m into Ke. So lambda is inversely proportional to root over m into Ke. Why? Because here 2 is constant, just remove that. H is Planck's constant, that also constant, remove that. If you remove that constants by using the proportionality symbol, and now the formula became like this: lambda proportional to 1 by root over m into Ke. With that, here we are taking that lambda 1 by lambda 2 is equal to root over m2 by m1 into K2 by K1. m2 by m1 into K2 by K1. So this is another relation between the de Broglie wavelength, mass as well as kinetic energy of the particle. Okay, and then next important topic, And here we are taking the another thing, that is the relation between the de Broglie wavelength and the potential. Relation between the de Broglie wavelength and the potential. Okay, how come we consider the relation between the de Broglie wavelength and the potential? And very simple, as you know that in the electrostatic potential and capacitance, we have the formula V is equal to W by Q. That implies work done, W is equal to V into Q. W is equal to V into Q. Okay, and now substitute here lambda is equal to H by, just now we have seen the formula root over 2m into Ke. Just now we have seen this formula, right? So all of you follow this, it's very important. Just take a look and write down. Lambda is equal to H by root over 2m into Ke. Now just now we consider that work done is equal to potential into charge. So whatever the work is done onto the charged particle, that can be stored as kinetic energy of the charged particle, nothing but kinetic energy in the charged particle. So here W replaced with Ke. It means lambda is equal to H by root over 2m into Ke is nothing but what's the value? Vq. Ke is equal to what's the value here? V into Q. V is the potential and Q is the charged particle, magnitude of the charge. Okay, and now this is the formula, lambda is equal to H by root over 2m into Vq. Now again we are taking the relation lambda de Broglie wavelength is inversely proportional to mass of the charged particle, square root of mass of the charged particle, potential as well as the charge, magnitude of the charge. Now with that, lambda 1 by lambda 2 is equal to root over m2 by m1 into v2 by v1 into q2 by q1. m2 by m1 into v2 by v1 into q2 by q1. Just remember this. Here capital V represents the potential in which the charged particle is passing, and Q is the magnitude of the charge. Okay, so now after taking all these considerations into the topic of de Broglie wavelength, now we are taking into another one, and that is for various charged particles, how come you calculate the de Broglie wavelength? So finally we concluded with some formulae, and those formulas straight away I am using here. Just this is a glance for your coming NEET exam, right? So now lambda is equal to, as you know that here we are taking the de Broglie wavelength for electron. So the de Broglie wavelength for electron is 12.27 by root V. V is the potential. So then this value is in Armstrong units. Otherwise here we are taking that root over 150 by V Armstrong units, root over 150 by V Armstrong units, right? And then this is for electron, and this is for electron. And now here next we are taking that for proton. So for proton here we are taking that de Broglie wavelength lambda is equal to 0.286 by root V, 0.286 by root V Armstrong units, and this is for proton. And then for neutron, so if you know all these formulas straight away in the problem, after reading the problem, if the in the problem whatever the particle is given, if it is electron, go for this, if it is proton, go for this. For the neutron, now whatever I am discussing to you, that you need to consider, that is same, de Broglie wavelength is equal to 0.286, remember this number, and root over, here we are taking the kinetic energy of the neutron, and that also in Armstrong units. Okay, and this is for neutron. And then for deuteron, and another charged particle for deuteron. So for the deuteron, de Broglie wavelength lambda is equal to 0.202 by root over V Armstrong units. And then this is for deuteron. The one more thing is nothing but for alpha particle, de Broglie wavelength lambda is equal to 0.101 by root V Armstrong units. Now if you take a look on this de Broglie wavelengths of all these charged particles for electron, for proton, for neutron, and for deuteron and alpha particle, and thereby you will get the immediate formula for which you are going to use in the respective problem. Okay, the another thing is nothing but here we are taking one more important formula in the de Broglie hypothesis is the relation between the de Broglie wavelength and the temperature. Okay, so how come we consider that? As you know that lambda is equal to, what's the formula of lambda? Previously we considered that lambda is equal to h by root over 2m into ke, then with that, here we are taking that in the lesson kinetic theory of gases, we have the concept that is kinetic interpretation of temperature. Ke is equal to 3 by 2 kT. Then with that, here we are taking the concept in the place of Ke, I am writing 3 by 2 kT. Here K is the Boltzmann constant, right? Lambda is equal to h by root over 2m into Ke. Ke is nothing but 3 by 2 kT, and 2 get cancelled here. Then lambda is equal to h by root over 3m kT, where T is the absolute scale of temperature, h is the Planck's constant, K is the Boltzmann constant, and 3 is the number that also constant, where m and T are the variable, mass of the particle as well as absolute scale of temperature, T also variable. Then relation between the lambda, m as well as T is lambda is inversely proportional to root over m into T. Simply we are taking it as root over mt. Now with that, so just take a look, don't deviate from this class, it's very important to you. Then lambda 1 by lambda 2 is equal to root over m2 by m1 into t2 by t1. So now just I am taking a small example, for this. Then for neutron, nothing but if the neutron is under some temperature, and thereby here we are taking the concept it as a de Broglie wavelength of that particular charged particle is nothing but 30.8 by root over T Armstrong units, where T is the absolute scale of temperature. Lambda is equal to 30.8 by root T, where T is the absolute scale of temperature. This we got in Armstrong units. Okay, the another one. So here I am whatever the formulae, whatever the problem you will get straight away if you remember the given data, then immediately it is easy to do the problem within 1 minute. So how come? At first, for that you need to remember the data, nothing but remember the statement which I am giving now. Okay, now so here I am taking the two particles, and those two particles having the masses m1 and m2, two particles of masses m1 and m2, and these two particles are moving with the velocities v1 and v2. Very simple, two particles having the masses m1 and m2, and these two particles are moving with the velocities v1 and v2. Okay, so now here, and the topic is nothing but initially these two are moving with initial velocities u1 and u2. Collision takes place. After collision, these two are attained the velocities v1 and v2. Very simple. Initial velocities are u1 and u2. Final velocities are v1 and v2. Before collision, after collision. Now here we are taking the concept as what about the ratio of de Broglie wavelengths? So for that purpose, here I am taking that lambda is equal to h by p. What is the relation? Lambda is inversely proportional to p. That is lambda 1 by lambda 2 is equal to p2 by p1. Lambda 1 by lambda 2 is equal to, what's the formula? P2 by p1. And then here we are taking that p2, momentum after collision. So momentum after collision is m1 v1 plus m2 v2. This is the momentum after collision. And then what about the momentum before collision? P1, m1 u1 plus m2 u2. Now if the collision is elastic collision, if the collision is elastic collision, so according to law of conservation of momentum, the momentum before collision is equal to momentum after collision, and thereby here you will get it as this value is 1 by 1, nothing but these two can be cancelled, then that value became as 1 by 1. Okay, and then next one. Next one. So now here if the collision is inelastic collision, nothing but perfectly inelastic collision. Perfectly inelastic collision is nothing but, what is the meaning of that? The after collision both the particles are stick together and moves with the common velocity, then that is nothing but inelastic, perfectly inelastic collision. In that case, what about the de Broglie wavelengths? And here lambda 1 by lambda 2 is equal to, as you know, that P2 by P1. P2 by P1. Now in this case, here we are taking that P2 after collision, that is nothing but mass is m1, another mass is m2, and both the masses are moving with the common velocity v, and before collision m1 u1 plus m2 u2. Whether that is elastic collision and whether that is inelastic collision, here the momentum is conserved. So momentum before collision is equal to momentum after collision, again these two can be cancelled, thereby here again we will get it as 1:1. Okay, then another one. So if you remember these data, these important statements, then it is easy to get out from the concept, as same as it is easy to know which formula we need to apply, and within the short span itself we can come out with the answer. Okay, and now, so here one more important topic, that is if a charged particle of charge q, so for example here we are taking the charged particle of charge q, and mass is m, mass of the particle is m, charge is q, and these two are moving with the velocities, nothing but initially, though that is moving with the velocity v bar is equal to v naught I cap, okay. Now here, and where it is moving in the uniform electric field, what is the value of the magnitude of electric field? So that is nothing but E bar is equal to E into I cap. Velocity is v naught I cap and electric field is E into I cap. So at this time, what we need to find out? Here we need to calculate the de Broglie wavelength of the particle after t seconds. De Broglie wavelength of the particle after t seconds. So listen, once again I am repeating. The mass of the particle is m, having the charge q, moving with the velocity v bar is equal to v naught I cap. In the uniform electric field, E bar is equal to E I cap. Now we need to calculate the de Broglie wavelength of the charged particle after t time. De Broglie wavelength of the charged particle after t time. Here we need to calculate. So for that purpose, here we are taking the concept it as so as you know that equation of motion, V is equal to what's that? U plus AT. V is equal to U plus AT. V bar, U bar, A bar. So V bar is equal to U bar. Initially what is the velocity? That is V naught I cap. So at the same time plus here, as you know that according to the topic of electric force F is equal to EQ. According to Newton's second law, EQ is equal to MA. According to Newton's second law, what is that? EQ is equal to MA. Okay, so now EQ equal to MA, and then with that A is equal to what's the value? EQ by M. A is equal to EQ by M, right? So now substitute this A value here, EQ by M into T. So here E represents E bar. Now what about E bar? V bar is equal to V naught I cap plus E I cap into Q by M into T. Then V bar is equal to V naught I cap plus EQ by M into T, and both we are representing it as I cap. Both we are taking it as I cap. Okay, and then with that here we are taking the concept V bar is equal to, in this I cap, in this also I cap is present, take out the I cap as common, then V naught EQ by M into T, and both, from both I cap is common. Then if you want to take the magnitude, modulus of V bar is equal to, V is equal to, modulus of I cap is equal to 1, that is the unit vector. So V naught plus EQ by M into T, VQ by EQ by M into T. Okay, with that lambda is equal to, it means after T time, this is the velocity. Now lambda is equal to, what's the formula? H by mv, that is equal to lambda by, sorry, lambda is equal to h by m. V is nothing but what's the value? V naught plus EQ by M into T. H by M into V naught plus EQ by M into T. And this is nothing but, here from this we are taking one more very important, that is H by M. Take out V naught as common. From this V naught as common, here 1 plus EQ T by M. Here no V naught is present, but in the denominator, after taking as common, then in the denominator we need to place the V naught. Now lambda by H M V naught, lambda is equal to H by M V naught. What is that? This is the H by M V naught. V naught is the initial velocity. So this is the initial de Broglie wavelength, and that's why here lambda is equal to, in the place of H by M V naught, we are taking it as lambda naught into 1 plus EQ T by MV naught, EQ T by MV naught. If any data will come across the problem as initial velocity V naught I cap, I am moving the electric field, E bar is equal to E I cap, then immediately you need to remember this formula, lambda is equal to lambda naught by 1 plus EQ T by MV naught. Okay, and now and then another important topic as content here. If a charged particle of charge Q, enters perpendicular to the uniform magnetic field, it means here we are taking uniform magnetic field. In this uniform magnetic field, a charged particle is entering, and when the charged particle is entering, how it is entering? Perpendicular to the uniform magnetic field, and this is the B bar. Charged particle Q is entering with the velocity V. Once the charged particle enters into the magnetic field, then it follows the circular path. That circular path having the radius is R. Now immediately here we are taking the topic it as, and that is whenever any body or particle is in the circular path, the essential force or necessary force is a centripetal force. So that centripetal force is nothing but mv square by r. Now here we are taking that this is nothing but produced by magnetic force, Fb. Fb is the magnetic force. Magnetic force creates the necessary centripetal force to the charged particle to revolve in the circular path. Thereby Fb is equal to, what's the value? mv square by r. Fb means what? Bqv. Bqv is equal to mv square by r, and Vv get cancelled. Then with that r is equal to radius of the circular path, r is equal to mv by, take the cross multiplication, and then this r goes to here, bq comes to here, r is equal to mv by bq. Now with that, here we are taking one more important topic. This is the radius of the circular path. Then here with that we are taking the concept it as mv is equal to momentum, mass into velocity, momentum is equal to cross multiplication bqr. De Broglie wavelength, lambda is equal to, what's the formula? H by mv. Now mv replace with what? bq by r. H by bqr. mv replace with bqr. Okay, and now so another one is nothing but here we are calculating the de Broglie wavelength for the electron which is revolving in the nth orbit. So for that, here de Broglie wavelength, remember this one very important point, remember this carefully. if the electron is revolving in the nth orbit, if the electron is revolving in the nth orbit, then how come we take the relation between the de Broglie wavelength and the number of orbit? De Broglie wavelength and the number of orbit. Lambda is directly proportional to n. Very, very important relation. De Broglie wavelength is directly proportional to the number of orbit in which the electron is revolving. In which the electron is revolving. Okay, and now here one more. So all this data, if you remember, then it is easy to do the numericals in the concept of de Broglie hypothesis. Okay, so at this exam time, I am giving a glance related to the all formulae which we get in these lessons. So not only this lesson, within 1 or 2 days, nothing but tomorrow or day after tomorrow, in these 3 days, you will get all the details related to the all the lessons, nothing but very, very important lessons for NEET as well as EAP set, and that is atoms, nuclei, dual nature, and then semiconductors, current electricity, waves, okay, alternating current, and all these lessons you will get the glance, nothing but synopsis. Whatever the formulae, you need to focus towards the problems that you will get. Okay, just take a look, and these 3 days you keep on search my channel, that is ABN Physics. Okay, here one more important point I am taking here. The ratio of wavelength of the photon to a particle of same energy E becomes, here I am taking that lambda photon. So lambda photon is nothing but, here we are taking that hc by E. This is the wavelength of the photon. Okay, and then this next time, here we are taking that lambda, nothing but wavelength of the particle. Wavelength of the particle is nothing but h by root over 2m into ke. H by root over 2m into ke. This is the formula. Okay, so from where you got this formula? E is equal to, what's the formula? hc by lambda. Then lambda is equal to hc by E. This is energy of the photon. Ke is the kinetic energy. M is the mass of the particle. Okay, then with this, here we are taking further. Then we need to take the ratio between these two. Lambda photon by lambda particle. As you know, this is the de Broglie wavelength, lambda particle. As you know, this is the photon from the concept of E is equal to h nu. Nu is equal to c by lambda. Then E is equal to hc by lambda. Okay, lambda photon by lambda particle. So then you will get it as lambda photon by lambda particle is directly proportional to the, here we are taking that kinetic energy, that is 1 by root ke. So kinetic energy is that 1 by root ke. So it means lambda photon and lambda particle having the direct relation as 1 by root ke. Okay, so with this, and this ke itself is, we are taking it as energy, and that is root E, energy. Now here we are taking the concept in the place of h by root over 2m into E, and now I am taking this formula and this formula, and these two I am taking now. Lambda photon by lambda particle, lambda photon by lambda particle is equal to, after taking the concept, that is hc by E whole divided by h by root over 2m into E. Now h get cancelled, and now this fraction can be reversed. Root over c by E root over 2me. Okay, then if you send the E into the square root, that became a square, that is nothing but root over 2me by E square. If you send this E into the square root, that became as E square. Then 1e get cancelled. Now the lambda photon by lambda particle is equal to C into root over 2m by E. This is very, very important formula. Remember this. The de Broglie wavelength, the wavelength of the photon and wavelength of the particle, if you take the ratio lambda photon by lambda particle is equal to C into root over 2m by E. Here C is the speed of light, E is the energy of the photon, and m is the mass of the charged particle. Okay, and this is one more important. And now with this we are taking the concept, I want to take the lambda photon. So lambda photon is equal to, here how come we consider that? How come I consider that? And that is here lambda photon is equal to C root over 2m by E into cross multiplication lambda particle. Cross multiplication is lambda particle. Okay, and now another important one. Here we are taking the ratio of de Broglie wavelengths of the photon as well as the particle. With the particle is moving with the velocity v. The particle is moving with the velocity v. Remember this carefully. Here we are calculating the ratio of de Broglie wavelength of the photon to the wavelength of the particle. So that particle is moving with the velocity v. In the problem, if they mentioned as the particle is moving with the velocity v, then what is the ratio of the de Broglie wavelength of the photon to the wavelength of the particle? Then immediately you need to take the formula, that is 2c by v into and that is energy of the particle and energy of the photon. 2c by v into energy of the particle by energy of the photon. This is another important formula. With this we are taking two cases. What are the two cases here? So here the first one is nothing but if E particle is equal to E photon, these two are equal. Energy of the particle as well as energy of the photon both are same. E particle is equal to E photon. Then these two can be cancelled. What about the ratio? Lambda photon by lambda particle. Lambda photon by lambda particle is equal to what's the value? 2c by v. Then another important second point in this, if these wavelengths are equal, previously energies are equal, now wavelengths are equal, nothing but this can be cancelled. At that time the cross multiplication can be done. So if you take the cross multiplication, E photon by E particle is equal to 2c by v. Previously lambda photon by lambda particle is equal to 2c by v. Now if the wavelengths are equal, then E photon by E particle is equal to 2c by v. Okay, so just take a look on this topic related to the de Broglie hypothesis, and then you will get 100% you will get a very good idea in the exam. Okay, so just take a look on my channel, and that is ABN Physics.